Example 4. Create a split stem plot of the data in exercise 3 and then describe the new distribution. So remember example 3, it did look a little bit scrunched on the x-axis when we were just counting by ones. Stem, x-axis, very similar ideas, working mostly the same way. So what if we count by a half, basically, and spread out our data? What if we zoom in just a little bit so we can see some more variation? So now, the lower, or the first of our 20s is going to have all of the leaves that go from 0 to 4, which there aren't any, but we have 2 8s. Again, 21, we have 1 0, and then 5 to 9 goes in the second group. 22, we have 0 to 4, so 0, 2, 3, 4. And then 22 and higher, 5, 5, 6, 6, 7, 7, 7. This will also let us zoom in on the data a little bit more and see if my symmetric idea from 3B was actually correct, or if we get a better view by zooming in a little bit. Okay, 23s, we have 0, 0, 1, 3, and 4 for the first group, 2 5s and 2 9s for the second group. 24 just has a 0 and a 2 and nothing bigger. 25 doesn't have a 0, but it does have a 6. So now we need to describe the shape of the distribution. Was it actually symmetric, or was it a little bit skewed? It's a tiny, tiny bit skewed right, but if we gathered more data, I think that we would probably find something in the 19 area. Again, it's high in the middle, and just because there's a small gap doesn't necessarily mean that this is a skew. We need a bigger gap to make that skewed in any way. So I think that this is still symmetric, but now we have a better view. It looks more symmetric than that. Again, it's mostly symmetric, and mostly is good enough for small data sets like this. It has to be really, really skewed to the right, something like that. That would definitely be skewed right. But since we're still mostly high in the middle, even with a little bit of tail on the right, I would say this is still symmetric. But that's what split stem plots are for, just to get a different view of the same information and see, did we actually make the right assessment?